guys, welcome back to John's Workshop, and in this video this will be the third in the engine build series of the flame licker that I'm currently making. And in this video it's not going to be too exciting in terms of actual bits of the engine, but they're all bits that need to be made. So we're going to be making, I'm calling it support structure, so it's some aluminium parts basically, 3 off if I've got enough time to get all 3 in this week. So the first one being the flywheel crankshaft support piece, which is fairly simple, and then the second one being the cylinder base support that sits on the top of the bridge, and I'll show you that on the screen in a minute so you can see what I'm talking about. And then if there's enough time into this week's episode, I'm also going to get the base plate that the whole engine sits on made as well. That may or may not be in this episode, we'll see how we get on with time this week. So without further ado, we'll go to the command and control centre. I'm going to keep calling it that, it'll stick, and we'll go and have a look at the parts that we're going to be making in this week's episode. Okay guys, we're up at the screen. So the bits I'm going to be making in this episode are largely this is the cylinder support piece that you can see there that's supporting the cylinder. This is slightly thicker aluminium than the other pieces that I've already made, so we're going to be making this bit. There's quite a lot of holes and various different features that need to go into that, and then by the power of magic we'll just kind of do some of this, and you can see hopefully the second piece that we're going to be making is this support piece here that supports the end of the crankshaft. It's got a bearing in it to support the load at this end of the crankshaft and to support the flywheel as well. Once I've got all of those bits out of the way, we can then start on the exciting stuff, such as flywheels, cylinder, piston, valve gear, things like that. So I'm trying to get the, if you want to call it, the basic stuff out of the way first, so that I've got the engine support stuff done, and then we can start concentrating on the more interesting pieces to make and the more critical pieces, if you want to call it that, from a tolerance perspective. So I'll bring you back at the milling machine just shortly, and we'll start loading up our first bits of material to make these bits. We've got our first piece of aluminium here. I thought, you know, these are fairly simple parts really, not too exciting to watch, so I thought we'd use the opportunity to, maybe somebody who's just starting out might go the wrong way with this. So the way this has come out of the stock, these two faces here are as stock, so should be reasonably parallel to one another. I've had a file over them to make sure there's no lumps and bumps on both sides. The rest of the sides are all saw cut, so that's a saw cut. The 2 ends are a saw cut. There's only one other face that's stock, which is this one. So this is the side of the stock, so this face should be reasonably square to these 2 faces. So really I need to, before I do anything else, you know, this needs to be thinned out. Now I could go for thinning this out first, but it would mean I'm gripping on a saw cut face, which would have the, you know, potential to kick this in a direction. Then it becomes hard to control thickness and all the rest of it. So just from a learning perspective, you know, always go with what you've got that's good and known for a start. So I know, you know, these will be pretty parallel to each other and they'll be pretty square to this bottom face. So we're going to sit on this bottom face, grip on these 2 faces that we know are good, machine this top face, take some stock off it, and then we know we're parallel, you know, this way across the block. Then we'll flip that over, sit it down on the face I've just machined, and then we'll machine off this face and get this to finish size this way. We can then sit it in the vise that way, square the ends up, both ends, and also machine this down to thickness this way, and everything should be square to itself at that point. So that's how we're going to do it. That was useful to somebody. So we'll find our stock face, we'll just pop that down on the bottom of the vise, and we'll clean this top face up first. So I'll just get my knocker, we'll just make sure that's down. And I'll bring you back when we start machining. Right guys, we've got our first bit loaded in the vise on parallels, and then we've taken the parallels out because we're drilling very close to the vise jaws at both ends. This is the cylinder support piece, and I'm just going to put the edge finder in, pick up my edges, get my DRO set, and then we've got a pattern of holes to put in here. Right guys, we've got our central hole. That's not finished size, but that's been drilled with a drill that's not going to deflect, and I need to pick that hole up in the lathe and finish this centre piece off for the cylinder to sit in, as I don't have a boring head so I can't do it on the mill. I've drilled some 4 fixing holes here. Next thing is to counterbore these, and I know everybody's going to shout at me, and I will always call out bad practice, especially when I'm doing it. This is bad practice. So I've got an end mill in the chuck. Should never do that. Should always put an end mill in a collet chuck or in a collet. This is a 6mm end mill going into a 3mm hole in aluminium. I'm comfortable with doing that on this occasion for 4 holes, so I'm not going to go to the hassle of changing all the spindle out for that. So shout at me if you like. I know it's bad practice, but I'm doing it anyway. Don't copy it. Right guys, I've just turned this plate over. Unfortunately I remembered to set my vice stop before I did, so I've not had to re-pick up the block. I know I'm on 0, 0. I've now got a PCD of holes to put in that are not, so it's 4 holes at 90 degrees, but they're not on the centre line, so they're offset by 45 degrees. 2 ways I can do this, or 3 ways I can do this. There's actually probably many ways I can do it, but 3 main ways. I can sit and calculate the hole positions out manually using trig. Fairly simple, wouldn't take long, and all 4 hole positions will be the same. They'll just be pluses and minuses on the X and Y axes. I can use my DRO function that's got a PCD function on, which I've never used yet, so that's what I intend to do. Or I could use a good old Zeus book and run the calculations through the Zeus book that way and get the 4 hole positions. So on this occasion I want to try using the PCD function on the DRO, so I'll bring you to the DRO now and we'll pump the numbers in and see what happens. So we're at the DRO and I'm not actually going to pump, I don't think, any numbers in here. We'll see, because I've had a bit of a trial practice run with this just to make sure I didn't make a fool of myself on camera. I'll clean that up. So I think the numbers will be pre-stored in, but we'll run through anyway. So we're over 0, 0, so we're over our center position. We're going to press PCD function, and it's XY axis, which is that one. It's saying where's my center position, so it's 0, 0. For some reason it adds a 1. I don't understand what that's all about, but 1 micron's not going to make any difference if that's what it actually is. We're now saying what's our PCD, which in this case is 36 millimeters, so an 18 millimeter radius, so I don't need to put that number in. We're saying what's my start angle, so it's plus 45 degrees. What's my end angle? It's 225 degrees. How many holes are there in the pattern? And that's 4. And it's now saying go to my first hole. So all I now need to do is wind my axes until they say 0, 0. So we'll just do that now. So that's one of them. So that should be us over our first hole position. So I'll just bring you back at the mill and we'll put these 4 holes in. Right guys, we're moving on to our next piece, which is the flywheel crank support piece. And what I've done off camera is I've just put the 2 3mm tapped holes, fixing holes in there. So we're going to set that up now, and we've got 1 hole to put in the centre here, and then we've got some milling work to do on the outside of this, which is largely decorative, I think, not functional, but we'll do that while we're on the mill. And then this piece will be going over to the lathe as well for some boring out. Alright, we've got a 14mm drill, that's going to go through next. Solid carbide drill, and that's going to give us a hole that we can clock up on the lathe. Right guys, we've got our next setup. We've touched on the top and zeroed the spindle. We're just going to touch on this side, set my DRO, and then I'm working in to a shoulder down to a depth to clear out a rectangular section. So we'll just do that now. That's one side done. This is where we find out whether I've controlled the depth of my tapped hole correctly. So we've got the tapped hole there, and if I'd gone too deep with that, that would have broken through, but that's nicely contained. So that's one side done to size. I'll do the other side off camera, exactly the same. We're just going to notch the other side out, and then I'll bring you back and we've got some scallops to put in the top corners, which we'll do last. Right guys, we've got our first small piece of Victorian architecture, for want of a better word. So there's two scallops to go on the corners of these. What I've done is dug out the bit of fixture plate that I made up, or found when I made the fuel tank, and I'm using that again, same clamps, clamping this down. I've touched on with my cutter either side. This is a 10mm end mill. I've got a 5mm radius scallop to put in the corner, so I've wound in 5mm in my y-axis. I'm now going to pitch in till I reach 5mm in my x-axis, and I'm going to be using the quill to shave the material off down to the, so I just touch the base plate. So we'll see how that goes. There we go, right, that's got our two scallops put in the top. So next job now for this is to move to the lathe, do the finished boring for the bearing support, and also the same thing on the cylinder support plate. I've got some boring to do to take the cylinder. So I'll join you at the lathe in a minute when we're setting these up for the final operation, which is finished boring. Right guys, I've made a bit of a faux pas with this bit, really. What I should have done was what I did with the other bits was bored the central hole out and the bearing location first before I machined everything else, because I can't sit this back against the chuck because it's too small. So what I've had to do is set it up against a parallel, which is what I've done, and we've got it in and we've got it clocked in to within a couple of tenths all the way around the hole. So I'm happy that we're good, and I've checked the face is running out 2 or 3 tenths as well. I'm comfortable with that, but it's a good job I didn't film it because it would have been an hour-long episode. So trying to clock this in and get all these packers in the right place and faff around took quite some time. So you'll have to take my word for it that that's set up okay. So what we're going to do now is bore this out through all the way through to 15mm, and then bore our counter bore in the front to suit the bearing location. So we'll bring you back when we're doing that. There we go guys, that's got our support completed. So that's that one. Next job is to load up the cylinder base plate in the chuck, which should be a bit easier because it's a bit bigger, and we'll get that bored out to fit the cylinder. A bit easier on this one guys, central hole, plenty of size to press up against the back of the chuck. So what I've done is put the rotating centre in, and I'm just going to bring the jaws down until they just nip with a packing piece in. A lot easier to set up than that last setup. Just making sure it's square to the jaw. Give it a tiny nip, nothing tight. Take the revolving centre away, and we'll bring our DTI in to clock that up. Now what I've started using for jobs like this is just the DTI stand off the surface table with a lever clock on it. So much easier than messing around with mag stands and trying to get something in there at the right place. This is just dead quick and easy. So I'm just going to put a bit of weight on, and then we need to find the low spot, the centre, which is there, and I'll just move the clock, put you in a different position, and you'll see how close that's got with just putting the rotating centre in to set it up. Alright guys, that's as it was set. I'm just going to zero that now, make sure we're on 0. And this is as it went in with the rotating centre in it. So that's within 2 thou. So I'll just put that, get that right, get that clocked in. Couple of squeezes with the Allen key. I need to move the camera out of the way, so I'll do that off camera. We'll get that right, and then we'll bore the counter bore in this plate. There we go guys, that's got our counterboard on. There we go, that's our cylinder base plate done. So we've got the counterbore in there to hold the bottom of the cylinder, and then the 4 mounting holes in the back to clamp it down, and all the other mounting holes in this plate for the various other fixings. Right, there we go then guys, that's got our cylinder base plate done. Ready for, this needs a bit of final work on wet and dry to polish it. And we've got our bearing support piece completed. In this video, didn't get the base plate done in this video, wasn't enough time in the week, or probably enough time in this video for all 3 bits. So that's got those 2 bits done, and you can see there the 3 bits I made in the first episode. They've had the wet and dry treatment on them, so they've got a real fine finish on all the way around now. So they are ready for a Solvol metal polish final assembly. And then there's my fuel tank that I made in the second episode, that's now had the rectification. Well, it would help if I had it on the camera, wouldn't it? There we go, it's had the rectification work done where I'd got too much solder in the bottom. Just some very careful work by hand with a file, not in a machine, and then that's had an initial polish up using some Brasso. I need to do some more of that just before final assembly for the complete shiny finish, but looking very nice already. So I'll just move the camera and we'll wrap this episode up. So there we go guys, that's 2 more bits done for the engine. So happy with that, we're making slow and steady progress, no serious mistakes yet, which is good. And so as I said, we didn't get the engine base plate done, so that will probably be in the next video, and I'll tag something else in to go in with that to make a decent episode. And then that really then concludes a lot of the support structure pieces complete at that point, and we can start on the exciting bits like the cylinder head, piston, crank. They're all going to be very, very interesting to make, and the cam itself, the cam that drives the valve system, that's going to be quite an interesting one as well. So lots of interesting bits still to come. So thank you all for watching. I hope you're enjoying the series. Thank you for subscribing. Thank you to the new subscribers, and we'll catch you all very soon on another video when we'll be making something else.